Annyeonghaseyo, students. Today we're going to talk about bases and exponents. This is a great concept. The reason why is it simplifies ideas for us. And it does that using a base. Here we have a base 2. This is the number that's going to get multiplied by what? Well, it's going to get multiplied this many times, 3 times. So 2 times 2 times 2. There are a couple ideas that we developed in order to explain things, a lot of things in our life. You look down at the floor tiles in your home or in your school. Well, we can talk about square footage, okay? And the reason we do that is we're thinking about a base and exponent. In this case, we'll use s squared, or the side length squared. And another way of saying this is the second power. And the reason why we use this with a square is because it has 2 dimensions. It has length and it has width. The length and width of a square are exactly the same. And that's why we use one variable, like a side length squared. And that also gives us our area. So there are a lot of concepts all packed into one idea here. Now, a second thing is s cubed, or s to the third power. We do this because we developed a shape called a cube. And in a cube, we'll have all 3 side lengths. Okay, the length, the width, and the height exactly the same. Thus, we have 3 dimensions, length, width, and height, that are all the same. So these are 2 concepts that will be used over and over in mathematics and, while you're at home or you're shopping at Home Depot. Now, if we move into something that has an exponent of 4 or 5 or 6, now, there is no shape, okay? What shape goes with the 4th dimension? Well, that's something that we really haven't found something that we universally understand, okay? There's no square or cube that goes with the 4th power that, a lot of people understand or we use in our regular day lives because we live in 3D world. So, anytime you have a power over 3, okay, you'll just say s to the 4th power, x to the 4th power, 5 to the 4th power. All right, moving on. Just to make sure we understand, we have a base and exponent. Another word that we can use for exponent is an index, or we can even say the power, 6 to the 3rd power, okay? And it's just 6 times 6 times 6. Perfect. If we take a look at a couple examples, we'll start with this. Now, if we have a negative number with parentheses to an exponent, or to a power, remember, all you are doing, the exponent is telling you how many times to multiply what's in the parentheses. So negative 5 times negative 5, of course, gives us a positive 25. Now we go back to the example that we know probably best, just a whole number to the 2nd power, positive whole number. Of course, 5 times 5 is 25. Now, what happens, though, when we put a negative sign out front of some parentheses? Now, remember, if you think about PEMDAS, the first part of PEMDAS is parentheses. We always want to do what's in the parentheses first, and that's exactly what we will do. The other side of this is that the negative sign will just follow this through. Okay? It's not negative 5 squared. It's the negative of 5 squared. And in the end, we will get an answer of negative 25. Looking at the second example here, we have no parentheses, but we do have exponents. And that's the second part of PEMDAS. So, once again, what's going to happen is we are going to have to do the exponent. We're going to have to simplify this base and exponent first. And then when we do this, we keep that negative sign following through, and we do the actual simplification. So we have negative 5 times 5, and that gives us negative 25. So in the end, what you can see, these two will essentially produce the same answer, negative 25 and negative 25. But that can be a little bit tricky. All right, let's move on. Now we're into fractions with exponents. And there are a couple ways of looking at this. But the first way is if we have 3 over 4, We don't have to change the fraction. We don't have to freak out. But what we're going to do is we need to apply this exponent to both the numerator and the denominator. Okay? That is, in my mind, the best way of doing this. Now, 3 to the second power is 9. 4 to the second power is 16. But there is another way of thinking about this. Remember, we have this number, this fraction, 3/4 to the second power. So really it means 3/4 times 3/4. And you can do it this way as well if you want to write it out. 3 times 3 is 9. 4 times 4 is 16. And in the end, of course, voila, we get the exact same answer. So, same idea. Take another look at a problem. 1/5 to the third power. Okay? And in this case, remember, the 3 as the exponent goes to both the 1 and the 5. Nice. People sometimes will just use the 3 with the 1. No, no, no. Okay? And in this case, it would be 1 over 125. All right. And the last couple examples. Now we're going to get into our negatives. Okay? And I want to make sure that everyone feels comfortable with this. You have a negative 2/3, but remember, this is in parentheses. This is the number that we are working with. So what we're going to do in this case is I'm just going to write this out twice. Negative 2/3 times negative 2/3. We know a negative times a negative is a positive. And then you can go from there with 2 times 2 and 3 times 3. I feel like writing it out like this is the easiest way to see the negatives that you have to use and you have to think about. Okay? Just to really quickly give you a second example on this, let's say you had negative 2/3 to the third power. Well, if you write all of this out, it'll take a second, but what it will do is it'll allow you to see all the negatives. Negative times negative is positive. Positive times negative, negative. And then 2 times 2 is 4. 4 times 2 is 8. 3 times 3 is 9. 9 times 3 is 27. So if you want to play it safe, this is one way of going about it. And then the last problem, we have our negative sign, but where is it? The negative sign is outside of the parentheses. So we are going to carry that through the problem, right? We have our parentheses and we have our numbers. So this is 2/3 to the second power. That's why I've wrote this 2 times. The negative will just carry through the problem, all right? And then we just do the math. 2 times 2 is 4, and 3 times 3 is 9. So that's all there is to it. You just have to be very, very careful with where these negative signs are going to pop up on you. You also have to make sure that you apply this exponent to both numbers, the numerator and denominator. All right, good luck.